So today we're going to be discussing the foundation layout and limitations of timber trestle bridges during SHTF. Now this is the last part of the information you need to build timber truss bridges from logs or milled lumber during SHTF. What we're going to do is go to an older version of the Builder 1NC book for Navy training courses. This is one of the very early editions, and it is edition C as in Charlie. So the book number is NAVPERS 10649-C as in Charlie. Now, unfortunately, I've never found a master book that contains all of the different plans that I've encountered in Marine Corps, Navy, CB, and Army and Air Force construction manuals. There must be a book somewhere, but I've never found it. And if it doesn't exist, it's something the government should put together, because a set of standardized plans for all kinds of improvised and expedient construction would be a lifesaver in SHTF or World War III. Now on page 518 of this manual, it shows you how to use a tape and a plumb bob instead of a level or transit to set up this type of bridge. Now here we have an embankment or a stream bed, and it shows you how to use the tape, and it differentiates between the horizontal distance and vertical distance, and it shows you where to put your foundation and footings for your timber truss bridge. Now it's always best to have a concrete, a stone, or some kind of mortared rock base rather than a wooden one for a foundation. But in SHTF, wood may be the only thing you have. You may not have the mortar unless you make it yourself. So we're going to move ahead with a wooden sill as a minimal foundation for our timber truss bridge. Now, when we look down on top of the sill that we've been talking about, this is the timber trestle. You can see how these timbers are put underneath the sill to act as a footing. And then looking at it from the side, that bottom sill log or timber is sitting on the footing in the excavation area where your foundation would go. This one shows you leveling up your sill and foundation. The bottom sketch is you leveling the excavation. So what you want to do is make sure the dirt, rock, whatever is level that you're putting your sill on in your foundation. That's critical. If the soil or rock is not level, then it's very difficult to get your sill leveled up. What you may have to do is use high strength grout to level up a rock area. So if you have bedrock and you can't drill, blast it, chip it, or whatever, you may have to use some type of high strength grout to level that up before you put your sill foundation in. Now, here we have the drawing of one of the trestles. So you'll notice the sill is at the bottom, and your foundation boards would be going underneath of that, or your rock foundation, or your concrete. And you'll notice here that you have cross bracing, and it's showing the location of drift pins. It gives you the dimensions on the bottom of how everything is spaced. Now, when you're looking at this diagram, you'll notice it shows drift pins in the top. And on the bottom, you have these fish plate boards. So what you can do is, if you cannot find drift pins, you can use these fish plates top and bottom. You'll need to do those on both sides, and you're better off through bolting them. If you don't have through bolts, then you'll want to use spikes. Now, one source of drift pins in SHTF is if you have damaged buildings and rubble. A lot of times you can salvage 1 and 2 foot pieces of rebar that are straight enough to use as drift pins. So keep that in mind. You can use salvage rebar of the larger diameters as a substitute for drift pins. Now, instead of 1 drift pin, you may have to put 2 in if you can't find something in the 1-inch range. So on page 522, we have an example of a 2-story bent. So we have 1 bent located on top of a second bent. And the important thing here is the limitations. So a single-story bent has a limitation of 16 feet. So if this distance from here to here is more than 16 feet, you start to get deflection and the posts are no longer steady and capable of handling the load. So if you need a 20-foot trestle, what you could do is do a 12-foot or a 16-foot bent and make the difference in elevation up with a shorter second piece. And in here it's showing you how to do it because we're using a single cap here, so this is a continuous construction. And keep in mind, you can have this dimension from here to here and here to here less than 16 foot. It just can't be more. So with 12 by 12 inch timbers, your limitation due to deflection of the beams and bending under load is 16 feet in height. So you can't go more than 16 feet this way. So keep in mind, you can have 1, 2, 3 stories of these built together. So that's the limitation you have with timber trestle construction, is each bent has to be 16 feet or less with 12 by 12 inch timbers. Now, one of the last things I want to show you about timber trestles is if you're going to have I-beams that you salvage from somewhere, there are nailing patterns for using the spikes to connect both timbers and I-beams or H-beams. So when we're looking at this, you can see these different nailing patterns. Now, what we're showing here is a curb portion. So there's actually a timber here and another piece of wood beside it. And you can see the nailing patterns here. These two have a drift bolt. This one does not have any additional spikes other than a drift bolt. This one, you can see you have 2 spikes to help hold it down. And then here on the bottom, we show different ways of putting spikes in I-beams. You can drill holes if you have the equipment to do that. You can lock them with large head nails. You can bend nails over, and then you can actually put wood boards on top of the I-beam and nail the wood boards down. So keep this in mind for SHTF. This will come in handy for repair and construction. So please let me know if you want to see any more information like this. We'll see you on the next video.